Welcome to today's video. Today's video is for Advanced Geometry, Chapter 10, Section 2, Areas of Trapezoid, Rhombuses, and Kites. Now, one of the reasons why they do rhombuses and kites together is because, if you'll remember from previous chapters, we know that rhombuses and kites, the diagonals are perpendicular, and that's actually going to come into the formula. So again, for these formulas, I'm going to derive them, show you where they come from. At least for the trapezoid, I have a kind of a way that helps me remember it, and I'll give you that too. Okay, so the height of a trapezoid is the perpendicular distance between the bases. And the area of a trapezoid is half the product of the height and the sum of the bases. So the area is 1/2 the height, and then you add the bases together. Okay? So what I want to do is I want to derive this formula, and I'll do it up above. The easiest way to derive it is to draw another altitude over here. And what we end up getting is we end up getting a rectangle, and we end up getting two triangles. Okay, so what I'm going to do is I'm going to call one of these x. This is going to be b1, and we don't know what this is. Let's not make up a new variable. Whatever it is, it's going to be b2 minus b1 minus x. Okay. Now, what I'm going to do is I'm going to break down each of those formulas. So the trapezoid is going to be 1/2 of the base and the height of the first triangle. So this will be x, and this will be h. Go ahead. Oh.
Wow, it didn't work the first time. Sorry.
That's okay.
Bad news is.
Okay, and then the second part is the rectangle, so it's just going to be b1 times h. And then we also have the other triangle. Now, it's not isosceles, otherwise I could have made those triangles congruent, but this works for any trapezoid. So what I have is I have 1/2 the height and the bases added together. So I've got b2 minus b1 minus x times h. Okay, so what I'm going to do now is I'm going to rearrange this. And one of the things that I'm going to end up having to get rid of is x, because if you notice, x is not in this formula. So I am going to have to get rid of that. So what I'm going to do is I'm going to distribute. I get 1/2 x times h plus b1h plus, now I'm going to distribute the 1/2 and the h to each of these three terms in here. So I get 1/2 b2h minus 1/2 b1h minus 1/2, let's see, xh. Well, if you look here and you look here, you'll see that the x's cross out, or the terms involving x cross out. And so what I end up getting is b1h plus 1/2 b2h minus 1/2 b1h. Well, I can take the two terms that involve b1h and I can put them together. So if I take 1 bh and subtract 1/2 bh, I end up getting 1/2 b1h plus 1/2 b2h. And then the last thing I'm doing, I'm going to factor out the 1/2. I'm going to factor out the h. And notice what I get, b1 plus b2. Check. There it is. So I can derive this just using triangles and trapezoids. Another way that I like to think about this one is you can think of a triangle as a special trapezoid in which one base equals 0. So if you take a look at this triangle over here, maybe this base is 4 and this height is maybe 5, and then the other base up here is actually 0 because it comes up to a point. And if you use that formula, what happens is you get 1/2 the height, and b1 plus b2 is just the one base, and you get 1/2 base times height. So a lot of times that helps me if I actually just think about the trapezoid formula, and the triangle formula is just a variation of that in which one of the bases is 0. Finding the area using a right triangle. So we will have to find parts of trapezoids using trig. So we want to find the area of this trapezoid. So we know the formula is 1/2 the base 1 plus base 2 multiplied by the height. Notice my answers involve √3, so this is going to be a special right triangle. Now they give me both bases, that's awesome, but they don't give me the altitude. So here's what I can do. I can draw in the altitude. Now I know that this right side is going to be a rectangle, which means the opposite sides are going to be congruent, which means this is 5, which makes this 2. Now I can play around with my little 30, 60, 90 triangle. I know that this is if this is 60, this is 30, so this is the short side. I want to go to the long side, so this side is going to be 2√3, which makes the other side 2√3. Okay, so now I can plug it in. I get 1/2 the bases added together, 5 and 7 become 12, and then the height is 2√3. Easiest thing to do, I don't have any addition, so I can cross out like factors or factors that cancel out. So if I take 1/2 and I multiply it by 2, that becomes 1. And so this becomes 12√3. So my answer is 12√3 meters squared, since my units are meters. Done. The second formula we have actually works for rhombuses and kites. The reason why it works for rhombuses and kites is because the diagonals are perpendicular. Now this picture, they don't look like they're terribly perpendicular, but rhombuses and kites, the diagonals are perpendicular. Okay, so the area is always 1/2 the diagonals multiplied together. The cool part is if you have a rhombus is a square, or can be a square. So if you have a square, you can actually use this formula, or you can use the rectangle formula. So if you ever have a problem and they give you the diagonals and it's a square, you might want to not try to figure out what the sides are. You might just want to use this formula. So again, I'm going to derive this formula. I'll do it for a rhombus, but it works for either one. Okay, so let me draw a rhombus. I might draw it this way. So we're going to be given 2 diagonals. So maybe I'll call this x, and I'll call this d1 minus x, and I'll call this y, and I'll call this d2 minus y. Okay, so each one of these is a right triangle. So on the top I have 2 right triangles, and on the bottom I have 2 right triangles. So what I have is I have 1/2 x times y plus 1/2 d1 minus x times y plus the bottom ones 1/2 x times d2 minus y, and the last one 1/2, and then, oh, this one's going to be longer, so plus 1/2 d1 minus x and d2 minus y. So let's do what we did before. Let's simplify as much as we can. So we get 1/2 x and y. And eventually we need the x and y to disappear. So we've got 1/2 d1 minus 1/2 x. And then we also have plus 1/2 x d2. Oh, oops, these should also have a y in them. So this, oh. So if we multiply this all out, we get 1/2 xy plus, now we have got a 1/2 and a y that have to distribute, so 1/2 d1y plus 1/2, oh, sorry, minus 1/2 xy. Oh, there's the ones that can cancel. And then we have plus 1/2 d2x minus 1/2 yx. And then at the bottom we've got 1/2. Now this one we're going to have to FOIL out, so I'm going to put 1/2 and then I'll FOIL it. We get d1 d2 minus x d2 minus y d1, plus xy. Okay, so let's see what we can cross out before we even. These will cross out. That looks like it for right now. So we get 1/2 d1y plus 1/2 d2x minus 1/2 xy plus 1/2 d1 d2 minus 1/2 x d2 minus 1/2 y d1 plus 1/2 x y. Okay. So here 1/2 xy minus 1/2 xy, they're gone. I'm just looking for all the ones that can cancel. I have this, oh, you can't see it because I wrote it up here, but this minus sign. Actually, here's what I'm going to do. I'm going to move the minus sign down here. And so these cross out. I also have the y that needs to cross out. There it is. And so the only thing that's left is 1/2 d1 d2. There it is. So this works because they're right triangles, and a kite works the same way. One of the things we could have done, I actually kind of did it as a kite instead of a rhombus, but what we could have done with a rhombus is we also know the diagonals bisect each other, which would have made this easier. But I did it as a kite, so it works for either one. And that's it. Oh, actually, sorry, got one more problem. So for this one, find the area of the rhombus. So they give me a side length and they give me one of the diagonals. So a rhombus, the diagonals bisect each other. So this is 12. This is a 3, 4, 5 right triangle. If you take a look at each one of these, that has been multiplied by 3. So this is the 3 times the 4. This is the 5 times the 3. And so this is actually going to be, this is going to be 9. And so we can do 1/2 24 times 18. And so our answer will be 9 times 12, which is going to be 108. Double check your units, meters squared, all done. Thank you for watching. Have a great day.